Okay, this video is about the combined gas law. So up till now, we've learned the relationships of pressure and volume and temperature, and pressure and temperature. And we've learned that there are direct relationships in these two, and there's an inverse relationship in this one. And what we can end up doing is combine all of these formulas together to make this guy, the combined gas law. So now we aren't assuming that pressure, volume, or temperature is constant, but we are assuming that the moles are constant. Go look at the ideal gas law video to see what's going on with moles. But right now we're just focusing on 2 P's, 2 V's, 2 T's. It doesn't matter which pressure you use in this one as long as you have the same pressure unit on both sides. So atmospheres and atmospheres, or millimeters of mercury and millimeters of mercury. Volume, in this one it doesn't really matter. So if you want to stay in milliliters, you can. But be careful about milliliters versus liters, because when you get to the ideal gas law, you have to use liters. And then temperature, we have to use Kelvin. Okay, and this is how you get to Kelvin if you forgot. So I'm going to go ahead and use my guess method. I strongly recommend using this on the test just to make sure you're all right. And so I'm going to go ahead, I'm going to go through and read my problem and underline everything I've been given. So I have a volume of 400 mils at negative 23 degrees Celsius and a pressure of 39.99 kPa. What will its volume be at 227 degrees Celsius and 79.98 kilopascals? So wow, I have a lot of givens here. I'm going to go ahead and start writing out what I've been given. So the first volume I was given is 400 mils. And then my first temperature that was given was negative 23 degrees Celsius. But I need to get myself to Kelvin, so I'm going to go ahead and add 273. And because this is a negative number right here, it's really saying 273 minus 23. But if you just plug into your calculator exactly what this says, you should get 250 Kelvin. And then the first pressure I was given was 39.99 kilopascals. I was also given a second temperature of 227 degrees Celsius, but I need to get myself to Kelvin, so I'm going to add those guys together, and I believe this becomes 500 Kelvin. And finally, P2 is going to be 79.98 kPa. Okay, my unknown is going to be volume 2, right? They asked for the second volume. So on my test, the way that I would think through this problem, I'd say, okay, I have 2 V's, 2 T's, 2 P's. The only formula that we have that has 2 P's, 2 V's, 2 T's is this guy right here. So what I'm going to go ahead and do is I'm going to use the combined gas law, write out the equation that I'm using so I don't forget where I'm plugging stuff in. And then on substitute, this section right here, I'm going to start plugging them in exactly where they go. So P1 was 39.99 kPa. V1 was 400 mils. And T1 was 250 Kelvin. So sorry. Okay, P2 was 79.98 kilopascals. We don't know V2. And then T2 they gave us was 500 Kelvin. So this looks a lot like Charles' law and Gay-Lussac's law. You just might get stressed out because there's lots of numbers happening, but it'll be okay. Just trust me. So you're going to use the butterfly method or cross multiplication, whichever works for you. It's the same thing. And everything that's in this circle right here, I'm going to write it out for myself. 39.99 times 400 times 500 is equal to. Then I'm going to take my second circle, and I'm going to go right here. And I'm going to say, okay, 250 times 79.98 times V2. And to help myself, because I feel stressed, I'm going to go ahead and I'm going to simplify this by just plugging each side of the equation into the calculator. So I'm going to say 39.99 times 400 times 500. That ends up equaling a big number that I do not want to write out, but I will for you. Okay. And then I'm going to go ahead and multiply these two numbers together. So I'm going to say 250 times 79.98. And this becomes 19,975 times V2. So now this is a little bit easier to digest here. What I want to do is I want to get my x, or my v2, to be sad and lonely. So what I'm going to do is I'm going to divide it by whoever it's touching. And in this case, it was 1,975. I am struggling today. Okay. And then we're going to plug this guy right here into the calculator. So I'm going to say 7998000 divided by whoever's on the bottom, 19975. And I end up getting approximately 400, milliliters, right? Because we started in milliliters. If you did this in liters, though, if you did this by yourself, you would have gotten 0.400 liters, because the relationship between liters and milliliters is by 1,000, divided by 1,000. Okay, hopefully that helps you.